And welcome. I am Dr. S. Kritika and in today's video we will be discussing about concentration and solving problems based on concentration. Let's begin. Concentration refers to the amount of a substance present in a given amount of solvent or solution. It is expressed in mass per unit volume, moles per unit volume, mass, mole fraction, molality, normality, ppm, that is parts per million, ppb, parts per billion, parts per million per volume. Mathematically, it is expressed as amount of a component solute in a mixture divided by total of the mixture, that is the solution. The amount of the component in a solute in a mixture is usually expressed in terms of mass or moles. The total of the mixture can be expressed in volume or mass. Concentration is crucial as it determines the effectiveness, safety, and efficiency of chemical reactions, industrial processes, pharmaceuticals, and biological functions. It also plays a key role in environmental monitoring, food formulation, and water treatment by ensuring proper composition and quality control. Concentration can be expressed in different terms, and let us see some important ways in which concentration is expressed. First one is molarity. Molarity is defined as the number of gram moles of solute divided by liter of solution. Molality is defined as the number of gram mole of solute divided by kg of solvent. Normality can be expressed as number of gram equivalents of solute by liter of solution. The number of gram equivalents can be written as weight of solute by molecular weight of solute into valency by liter of solution. The other way in which we can express normality is molarity into valency. Next one is ppm, parts per million, which can be expressed as weight of the solute by weight of the solution into 10 raised to the power 6. Let us solve some simple problems in molarity, normality, and ppm. First problem, calculate the molality of the following solutions. So first solution they have given is 12.4 gram KCl in 289.2 milliliter solution. And we know the formula for molarity is number of gram moles of solute by liter of solution. So let us solve this problem. Given data in the problem is the mass of KCl is given as 12.4 grams and volume of the solution is given as 289.2 milliliter. So milliliter has to be converted into liter. So 289.2 into 10 raised to the power minus 3 liter. Molecular weight of the KCl is 74.55. So the formula is number of gram mole of solute by liter of solution. First we need to calculate the number of gram mole of solute. So number of gram mole of solute can be calculated by using the formula mass by molecular weight. Mass is given as 12.4 grams and molecular weight of KCl is 74.55. So the number of gram moles is 0.1663 gram mole. So now we have calculated the number of moles, then we can calculate what is molarity. Molarity is number of gram moles of solute, that is 0.1663 divided by volume of the solution, that is 289.2 into 10 raised to the power minus 3 liter. When you divide these two values, we will get the answer as 0.575 gram mole per liter, or it can be written as 0.575 molarity of KCl. So in this problem, mass of the KCl is given, volume is given. We have converted the milliliter into liter, and then first we have calculated the number of moles by using the formula mass by molecular weight, and then we substituted in the molarity formula number of moles by volume will give you the molarity. So now let us do the next problem. The given data in the problem is 16.4 gram of CaCl2 in 0.614 liter of solution. So the same question they have asked us to find out what is molarity. Molarity is defined as the number of gram mole of solute divided by liter of solution. So let us write down the given data in the problem. Number of mass of the calcium chloride is given as 16.4 grams, and then liter of solution is given as, volume of the solution is given as 0.614 liter. So from, we have to calculate number of moles. Number of moles is equal to mass by molecular weight. Mass is given as 16.4 grams and molecular weight of calcium chloride is 110.98. So we will get the answer as 0.1478 gram mole. Next, let us calculate the molarity. Molarity is equal to number of gram moles of solute, that is 0.1478 gram mole, divided by volume, a liter of the solution, that is 0.614 liter. So you will get the answer as 0.241 molality of calcium chloride. So next, let us solve some problems based on molality. First problem in molality, calculate the molality of 1.8 kilomole of KCl in 16 kilomole of water. So we know the molality formula is number of gram mole of solute by kg of solvent. First, let us write down the given data in the problem. See, the number of moles of KCl is given as 1.8 kilomole. And this is the solute. And the number of kilomole of water is given as 16 kilomole. And this one is the solvent. So as per the formula, the solute has to be given in gram mole. So convert the number of moles of KCl into gram mole as 1.8 into 10 raised to the power 3 gram mole. Then we need to calculate the kg of solvent. So the kg of solvent is nothing but the mass. The mass can be calculated by number of moles of water into molecular weight of water. So the number of moles of water given in the problem is 16. So 16 into 18 is equal to 288 kg of water. So now we have found out what is the number of moles of KCl, that is solute, and then mass of water. So let us now calculate the molality. Molality is defined as the number of gram moles of solute, that is 1.8 into 10 raised to the power 3 gram mole, divided by kg of solvent. Kg of solvent is 288 kg of water. So when you divide 1.8 into 10 raised to the power 3 divided by 288, you will get 6.25 gram per mole per kg or molal of KCl. Next problem is same molality. They asked us to find out 30 gram of C6H6 in 17 gram of CCl4. So here solute is 13 gram of C6H6 and solvent is 17 gram of CCl4. So we have to convert the gram mole of solute. So gram mole of solute is equal to, that is number of moles in gram mole is equal to the mass by molecular weight. 13 gram by molecular weight of C6H6 is 79 gram per gram mole. So you will get N as 0.1667 gram mole. So next we have to calculate the kg of solvent, but the data is given in gram. We have to convert that into kg. So mass of solvent is equal to 17 gram. So convert that to kg. 17 into 10 raised to the power minus 3 kg. So now let us calculate the molality. Molality is equal to number of gram moles of solute, that is 0.1667 divided by mass of the solvent, that is 17 into 10 raised to the power minus 3, which will give you 9.80 molar of C6H6. So till now we have discussed some simple problems based upon the molality and molality. Let us solve a problem with combination of mole percentage, mass percentage, weight percentage, molarity, molality, normality and ppm. The statement of the problem is, for a given HCl aqueous solution, the weight percentage of the solute is 30%. The density of the solution and water are 1149 kg per meter cube and 998 kg per meter cube. And the atomic mass of H is given as 1, Cl is 35.5, valence is 1. They are asking us to calculate the composition in mole percentage and volume percentage, molarity, molality, normality and ppm. So in the given problem, the solute is HCl and the solvent is water. And they have given us the density of HCl solution to be 1149 kg per meter cube and density of water is 998 kg per meter cube. Now let us solve the problem. To simplify the problem, we will make it out as a table and solve the problem. What is the data given in the problem? The weight percentage of the solute is 30%. And we have to find out using this 30% what is mole percentage, volume percentage and further molarity, molality, normality and ppm. And always we know that the total of weight percentage of a mixture or mole percentage or volume percentage is equal to 100%. So from this easily we can generate what is for the weight percentage of solvent, that is total minus solute. 100 minus 30 will give you 70%. Next, we can write down weight directly from weight percentage, that is 30 by 100 into 100. Weight of solute is 30, solvent is 70 and water is 100. So with this 100 only we are further going to do all calculations. So we can write down the basis of the problem as 100 kg of HCl solution. Next we have to calculate the number of moles. Number of moles is calculated by using the formula mass by molecular weight. So for calculating the number of moles we require the molecular weight. The molecular weight of HCl is 36.5 and for water it is 18. So now we can calculate the number of moles, that is individual mass is 30 divided by 36.5 is its molecular weight. The value is 0.8219. Next, to calculate for water, the individual mass of water is 70 and molecular weight is 18. You will get 3.3889. Now we have to make out the total. 0.0829 plus 3.3889 will give you 4.7109. So next, to calculate mole percentage, so the formula for mole percentage is individual number of moles by total number of moles into 100. So individual number of moles is 0.8219 divided by 4.7109 into 100 is 17.45%. Next, for water, 3.3889 divided by 4.7109 into 100 is equal to 82.55%. So next we have to find out what is volume. So we know the formula, density is equal to mass by volume. So density value is given. From this we can calculate what is volume. Volume is equal to mass by density. Density of the solvent and solution is given in the problem as density of the solution is 1149 kg per meter cube and density of the water is 998 kg per meter cube. So from this we can calculate the volume of solvent and solvent and solution. So for solvent the mass is 70 and the density is 998. 70 divided by 998 will give you 0.0701. And next, for solution, 100 by 1149 will give you 0.08703. And next, using the total and solvent, we can easily calculate what is for solute. So total minus solution minus solvent will give you the value for solute. So the solution is 0.8703 minus 0.0701 will give you the volume of solute is 0.01693. So done with volume. with volume, we can calculate what is volume percentage. Volume percentage is individual volume divided by total volume. Individual volume percentage is individual volume divided by total volume into 100. Individual volume is 0.01693 divided by 0.8703 into 100. That will give you 19.46 percentage. Similarly, for the second one, 0.0701 divided by 0.8703 into 100 will give you 80.57 percentage. So now with this table, we have calculated what is from the weight percentage, we have calculated what is mole percentage and volume percentage. So next question is, we have to calculate what is molarity, molality, normality and ppm. So molarity is the number of gram mole of solute by liter of solution. So the problem, we have to pick out the data, gram mole of the solute. So here the number of moles of solute is 0.8219 and the unit is kilomole. So we should write in gram mole. So 0.8219 kilomole into gram mole is 10 raised to the power 3. Gram mole divided by liter of solution. So solution volume is 0.8703 and the unit is in meter cube. So we want to convert meter cube into liter. We know 1 meter cube is equal to 1000 liter. So 0.8703. So converting into liter, it has to be multiplied with 10 raised to the power 3 liter. So when I divide these three, 10 raised to the power 3 gets cancelled and you will get the answer as 9.444 molarity of HCl solution. So next one, we need to calculate molality. Molality is number of gram moles of solute by kg of solvent. Number of gram moles of solute is 0.8219. 0.8219 into 10 raised to the power 3 gram mole, same conversion of kilomole into gram mole by kg of solvent. So mass of solvent is 70 by kg of solvent is 70. So 0.8219 by into 10 raised to the power 3 divided by 70 kg is 11.74 molar. So next, normality can be calculated by multiplying molarity into valence. So we know molarity is 9.44 in 4 and in the problem itself the valence is given as 1. So normality is 9.444 normal. And next let us calculate ppm. Weight of the solute by weight of the solution into 10 raised to the power 6. So what is the weight of the solute? Weight of the solute is 30 and weight of the solution is 100. So 30 divided by 100 into 10 raised to the power 6. So 10 gets cancelled. You can get 3 into 10 raised to the power 5 ppm, that is parts per million. So we have done with molarity, molality, normality and ppm. So similar type we will do one more problem based upon the mole percentage is given, and from that how will we be calculating the molarity, molality, normality and ppm. So in the next problem, sulfuric acid is the solute and the solute concentration is given in mole percentage as 36.8 percentage, and from this they are asking us to find out composition in mole percentage, volume percentage, molarity, molality, normality and ppm. So given data in the problem is solute is sulfuric acid, it is given as 36.8 mole percentage and the valence is given as 2. Density of the solution is 1681 and density of water is 998 kg per meter cube. Now let us solve the problem. So the data given in the problem is mole percentage is 36.8. So from this we have to calculate what is weight percentage, volume percentage. So the given problem, the solute concentration is given as 36.8. The given percentage, the concentration of the solute is given as 36.8 and we know that total is 100. 100 is the total mole percentage. So we can easily find out for solvent, 100 minus 36.8 is 63.2 for solvent. This is percentage, and we can directly convert that to number of moles, that is 36.8 by 100 into 100 is 36.8, and this one is 63.2 and 100. So with this 100 only, further we are going to calculate what is weight percentage and volume percentage. So the basis of the solution is 100 kilomole of H2SO4 solution. So next, for calculating the weight, we know the formula. Number of moles is equal to mass by molecular weight. Therefore, the mass or weight is equal to number of moles into molecular weight. So, we should know the molecular weight of sulfuric acid. The molecular weight of sulfuric acid is 98. The molecular weight of water is 18. So, the mass can be calculated by number of moles into molecular weight. That is 36.8 into 98. That will give you 3606.4. And next one, 63.2 multiplied by 18 will give you 1137.6. Next, to calculate weight percentage, individual mass by individual weight by total weight into 100. So we need the total 3606.4 plus 1137.6 will give you 4744. Next, to calculate weight percentage, individual mass divided by total mass into 100, that is 3606.4 divided by 4744 into 100 will give you 76.02 percentage. And next one, 1137.6 divided by 4744 into 100 will give you 23.98 percentage. Next, we need to calculate the volume. As same way, the volume of the solvent water is given as 998, and for the solution it is given as 1681. So we know the formula, density is equal to mass by volume. So from this, volume is equal to mass by density. So we cannot find for solute, it's not given density. So first let us find out for solvent. So solvent mass is 1137.6 divided by 998. 1137.6 divided by 998 will give us 1.140. And next one is 4744 divided by 1681 for solution. It will give us 2.822. So we know total volume and we know the volume of the solvent. So the volume of the solute can be calculated by subtracting the total minus volume of the solvent. That is 2.822 minus 1.140 will give us 1.682. So from this, next we can calculate what is volume percentage. Volume percentage is the individual volume divided by total volume into 100. So individual volume for the solute is 1.682 divided by total volume is 2.882 into 100 will give us 59.6 percentage. And next one is for solvent water, 1.140 divided by 2.882 into 100 will give us 40.4 percentage. So now we have calculated weight percentage and volume percentage. Next, let us calculate what is molarity, molality and normality. Now, molarity is defined as the number of gram moles of the solute by liter of the solution. Number of gram moles of the solute is 36.8 kilomole, but in the formula we need in gram mole. So 36.8 kilomole into gram mole is that, multiply that with 10 raised to the power 3 divided by volume of the solution in liter. So the volume of the solution is 2.882 meter cube, but we need in liter. So 1 meter cube is equal to 1000 liter. So 2.822 into 10 raised to the power 3 will give you in liter. 10 raised to the power 3 gets cancelled. So you will get answer as 13.04 gram mole per liter or molality of H2SO4 solution. So next, to calculate molality. Molality is gram moles of solute. Same, 36.8 into 10 raised to the power 3 divided by kg of solvent. So what is the kg of solvent? 1137.6. kg of solvent is 1137.6. 1137.6. So you will get 32.34 gram mole per gram or It is molal of H2SO4 solution. Next one, normality is calculated by using molarity into balance. So molarity is 13.04. 13.04 into valence of sulfuric acid is 2. So multiplied by 2 will give you 26.08 N. Next, let us calculate what is ppm. ppm is weight of the solute by weight of the solution into 10 raised to the power 6. Weight of the solute is 3606.4 and weight of the solution is 4744. So let us divide 3606.4 divided by 4744 into 10 raised to the power 6. So you will get 76020.24 ppm. So now we have calculated molarity, normality and ppm. So in this session we have discussed about the basic concept of concentration and what are the various ways in which we can express concentration and solve some simple problems based upon molarity, normality and ppm. Thank you.